Good day, my viewers. It is another time to study mathematics, and the topic we're studying this time is circle theorems. We want to look at the 8 basic circle theorems we have in mathematics. And before that, we need to take note of the parts of circle, because as we'll be coming across some circles charts, we need to know each part. The first circle here shows us the radius. The second one shows us where the sector is. That black shaded portion is the minor sector, and the larger part of it is the major sector. We also have the minor segment and the major segment at that yellow portion. After that, we have the arc. The arc is what is pointed at with an arrow. We equally have tangent to a circle. When we have a tangent to a circle, that is a straight line that touches the circumference. We can see it. The circumference is that turn that goes around a circle. So also we have chord. The chord touches the two circumference. It touches the first side and the second side, and that is what an arrow is pointed at. We also have what we call diameter. Diameter runs through the first side of the circumference to the second side of the circumference, through the middle, through the center of a circle. And in fact, diameter is the longest chord we ever have, and that runs through the center of the circle, as we can see. So now let's go to the 8 circle theorems we have. Number 1, all the circle theorems are listed here, and we'll be taking them one after the other. The first one, the angle at the center is twice the angle at the circumference. What do we mean by this? Meaning, at the circumference, look at that point D and look at that point A. Point A is at the center, point D is at the circumference. The angle at the center, point A, is 150. We take for instance, so half of that is what is at point D at the circumference. Or we say it other way, the twice of the angle at point D is equal to the one at the center. 75 times 2 is 150. That is the first theorem that we have. And the second one is the angle in a semicircle is 90 degrees. Angle in a semicircle is when we have half of a circle. This is what we call a semicircle. And in fact, this angle that happen to be at 90 degrees, meaning that triangle in a semicircle is a right angled triangle. At that circumference, we have 90 degrees at point C. So angle in a semicircle is 90 degrees, and it is indeed a right angled triangle. Let's take note of that. Number 3, angles in the same segment are equal. We have shown us what a segment is. Point C and point D, they are both in the major segment, as we can see here. And angle at the same segment, in the same segment, as we can see, they are equal. So angle at D is equal to angle at C. That is another theorem. Let's take note of that. Number 4, opposite angles in a cyclic quadrilateral add up to 180. What do we mean by this? Two angles that are facing each other, they are opposite angle, and when we sum them together, they must be equal to 180 degrees, provided that it is a cyclic quadrilateral. What do we mean by cyclic quadrilateral? Is a quadrilateral that is inside a circle, and all the 4 angles touches the circumference of a circle. As we can see, angle at point C plus angle at point E when we sum them up, it must be equal to 180. Angle at point D and angle at point F, when we sum them up, it must be equal to 180. Let's move on to number 5. The length of the two tangents from a point to a circle are equal. What do we mean by this? Look at tangent CD and tangent CE. The length of these two tangents are equal, provided that they are both tangents on a circle. They are both tangents on a circle, and as we can see, this is practically possible. All these sketches are drawn to scale and they are measured indeed before we can conclude and turn them to a theorem. So the length at CD is equal to the length at CE. Let's move on to the next one. Number 6. The angle between a tangent and a radius in a circle is 90 degrees. What do we mean by this? When we have a tangent and a radius is meeting at the same point, looking at that point D, where the radius AD meets tangent CD. So the angle at this point is measured 90 degrees. The same thing to the other one here, tangent CE and radius AE, where they both meet, it is at 90 degrees. Let's move on to the next one. Number 7. Please let's be very careful at this one. The angle A. What do we mean by angle A? The angle A between the tangent and the chord at the point of the contact D is equal to the angle B in the alternate segment. Let's take note of this very carefully. The angle alpha, look at where angle alpha is located, down here at point D. The angle alpha between the tangent and the chord, take note of it very carefully. We have tangent CD and we have chord DF. So the angle alpha between the tangent and the chord at that point D, where I just mentioned now, is equal to the angle beta in the alternate segment. The angle beta in the alternate segment is located right here at point E. Let's take careful note of this when we are having different shapes and different diagrams. If we can study all these 8 theorems and we see any of them that are looking alike, we can easily key in and make use of the theorem correctly. And the next one, which is the last one, perpendicular from the center bisects the chord, meaning that when we are having a perpendicular coming from the center, just like that of radius, it bisects the chord. When we have a chord of a circle, just like this chord CD, and we have a perpendicular straight line coming from the center, so it bisects the chord at point E, meaning that it divides the chord into equal half. And when we have a bisecting straight line coming to bisect a line, it bisects it at angle 90 degrees. So these are the 8 theorems we have. When we come across exercises that has to do with applying any of these, let's make use of them correctly. Thank you so much for watching. Do have a nice day.